Hello everyone, welcome to YourPedia, welcome to our HPCL question series. So this week I'm going to cover network analysis, which is common for electronics and instrumentation engineers. Let's start with the questions. See, one thing I want to tell you before I start is the question levels of HPCL is very easy. So these are all the questions or models of the questions which are very much relevant for HPCL examination preparation, right? Let's enter into the first question. The very first question is in the circuit shown below, the power supplied by the voltage source is, so there is a voltage source is saying, yes, there is a voltage source of 15 volts. So he is asking how much is the power supplied by that voltage source. Now observe it. For that we have to find the currents. So what I do is, this current is 0.5 amperes. You see, this current is 0.5 amperes. So I assume this current has some I, and I write the KVL for this loop. Then what I'm going to get? I'm going to get it as minus 15 plus 60I plus I plus 0.5. See, at this node, I is coming as well as 0.5 is also coming. I plus 0.5 into I plus 0.5 into 120 is equal to 0. Right? I need current I. So minus 15 plus 60I plus 120I plus 60 is equal to 0, because 0.5 into 120 is 60, right? So this is 180I is equal to 60 minus 15. 60 minus 15 is how much? 45. So when I take that side, it will be minus 45. Therefore I is equal to minus 45 by 180. So 9 5s, 9 20s. So 5 4s it is. So it is minus 1 by 4, that is equal to minus 0.25 amperes. What does it mean by minus? So I assume the direction of current this way, but actually the current of 0.25 amperes is flowing this way. So I can write 0.25 this way, or I can write I is equal to minus of 0.25, both are same. So here current is entering into the positive terminal. The question is power supplied. So a source will supply, a DC source, I am talking especially for this source, this will supply power from positive terminal current is leaving, but into the positive terminal current is entering. How much it is? 0.25. It is not supplying, it is absorbing power. But the question is about power supplied. It is absorbing a power of V into I, it is supplying a power of minus VI. So power is equal to 15 into, yes, minus 0.25, that is equal to P is equal to how much it is? Yeah, 1.5 into 2.5. 1.5 means 3 by 2 into 2.5 means 5 by 2. So 15 by 4, how much it is? 15 by 4 means I can say 7.5 divided by 2. 7.5 divided by 2 means minus is there, minus 3.75 watts. Minus 3.75 watts. Option is B. Option B. Direct question, simple question. Let's go to the next question. Two capacitors C1 and C2 are in parallel. C1 is equal to 100 microfarad, C2 is equal to 50 microfarad. What is the total energy stored with a steady state applied voltage of 1000 volts? So this is a direct question. Yeah. What is the formula for energy stored of a capacitor? EC is equal to half C VC square, where VC is the voltage across capacitor. Here half means 0.5 into C equivalent, as two capacitors of C1 C2 both are connected in parallel, then the resultant capacitance will be 150 microfarad. 150 into 10 to the power of minus 6 into voltage is 1000 volts. 1000 square is 1000 means 10 cube, 10 to the power of 6 it is. This gone. So it is 0.5 into 150 divided by 2, it is 75 joules. Option is B. Option is B. Let's go to the next question. An AC voltage is applied to an RL series circuit with a resistance of, see, he's saying that RL series circuit, this is R, this is L, voltage source is applied, voltage source is AC voltage source is applied, R is a resistance of 50 ohms and reactance is of 50 ohms, but reactance is written as JXL, J 50 ohms. When applied voltage with a sinusoidal varying voltage, the current flowing will lag behind the voltage by an angle of, is asking about theta. So this is I, this is V. So I is equal to simply V by Z. V is, let's take it as V at an angle theta, by Z is, what is Z? 50 plus J 50. The angle of V is theta. The angle of V is theta. Therefore, I is equal to V by mod Z at an angle of theta. This angle, see, denominator is 50 plus J 50. Its angle is tan inverse of 50 by 50, that is tan inverse of 1, that is 45. When it goes to numerator, it will be minus 45. Now, this is voltage angle, this total is current angle. The current angle is 45 degrees lagging, less. So this is voltage angle. So when compared to this voltage angle, the current angle is 45 degrees lagging. So answer is 45 degrees. Option is C. Let's go to the next question. Calculate the power dissipation in 3 ohm resistance. Yeah, so this is a 3 ohm resistance. He is asking us to calculate the power dissipation. Yeah, so power formula is I square into R or V square by R. So let's calculate in both the ways we can do. That question we can do in any of those two ways. So here all of you tell me 6 in parallel with 3 will be, see, these two equivalent resistance I can find, these two equivalent resistance. If I do, I'm going to get, this is 4 ohm and 6 in parallel with 3 will be 6 into 3 by 6 plus 3. 6 into 3 by 6 plus 3 is 9. So 3 3s, therefore it is 2 ohms. It is 2 ohms, right? And this is of 12 volts. If it is of 12 volts, the current is 2 amperes. Now this current is 2 amperes, then apply voltage division. I'm going to get I1. Now I redraw the circuit, 4 ohms, 6 ohm and 3 ohm. Yeah, this is 12 volts, this is 4 ohms. Yeah, this is 6 ohms, this is 3 ohms and this is I1. Yeah, I1 is equal to, see, what is the current division I am applying? 2 amperes into opposite resistance by total resistance, right? So I1 is equal to, yeah, opposite resistance 6 and 3. I want to find current I1. This is 2 amperes. Current I1 is equal to, total current is 2 amperes into opposite resistance 6 divided by 6 plus 3, 9. So 3 3s and 3 2s, it is 4 by 3. So power is equal to I square, 4 by 3 whole square into R is 3. So power is equal to 16 by 9 into 3. So you are going to get it as 16 by 3 watts. 16 by 3 watts. So how much will be 16 by 3? So 3 5s, definitely it will be 5.33. Option is B. Option is B. Simple question, that is also next question. So this question we are going to solve within one step. Okay, read it. He is saying that in the circuit shown below, the effective resistance faced by the voltage source is, so R is equal to V by I. R is equal to V by I. So from here effective resistance means from here we are finding. Now how much is, see, if this is I by 3, then how much is this current? I minus I by 3, that is 2I by 3, right? Yeah, if you add those two, here this is apply KCL. If you add these two, 2I by 3 plus I by 3 will be 3I by 3, nothing but I. Now write KVL. What is the KVL? This is plus, this is plus, this is minus. So minus V plus 2I by 3 into 3 is equal to 0. So this way I wrote KVL. This way I wrote KVL, right? So 3 3 gone. V is equal to 2I. So R is equal to V by I is equal to 2 ohms. How much it is? 2 ohms. That is the effective resistance. Option is C. Option is C. Let's go to the next question. the circuit shown below, the voltage VAB is asking the voltage here VAB. VAB is asking, not VBA. Please do remember, VAB is asking, not VBA. Okay, there is VAB is exactly opposite to VBA, right? Let's find what we do is yeah. See, any method we can follow, but I am thinking for a simplest method. I'm thinking for a simplest method. I'll go with the source transformation. Yes, that is easy for me. What is source transformation? Voltage source in series with resistance can be converted to current source in parallel with the resistance. By that, this voltage source 10 volts 5 ohms will be this way. 2 amperes, 10 by 5 is 2 amperes, and this is 5 ohms, right? And this is of 5 ohms, and this is B. Yes, this is B, and this is A. Yes, and this is, yeah, this is also I'll convert, this also I'll convert, no issues, I'll convert. So this is 50 and 10, but here current source will towards down. How much is the current source value? 5 amperes. Yeah, 50 divided by 10, right? And resistance of 10 ohms. Now there are two current sources in parallel, then both the values will be added, but 2 is up, 5 is down, therefore net will be 3 down. So I have a current source of 3 amperes to the down, and 5 ohms, this is 5 ohms, this is 10 ohms. So 5 in parallel with 10 will be, let's find how much it is. 50 divided by 15, 5 in parallel. Do not disturb this B and A, do not disturb that B and A 5 ohms. This is 2 amperes, this is 5 amperes, therefore down 3 amperes, fine. 5 in parallel with 10, 50 divided by 15. 50 divided by 15, yes, it is. Next is that is 5 ohms. This is B, this is A. So 5 threes and 5 tens, it is gone. Now how much is the current in this one? As it is there, current will flow this way, arrow is this way. Now let's find the current I. The current I is equal to 3 into opposite resistance is 10 by 3, by total resistance is 10 by 3 plus 5. 10 by 3 plus 5. Therefore, I is equal to 3 into 10 by 3 by, this is 15. 15 plus 10 is 25 by 3. This 3 gone. Now 3 into 10 by 25. So therefore, this is 30 divided by 25. So 5 5s and 5 6. The current I is equal to 6 by 5 amperes. Now what is VAB? What is VAB? Let me write here. What is VAB? VAB is equal to, the current is how much? 6 by 5 into resistance is 5. Therefore, it is 6 volts, very simply. Choice is D. But see, source transformation is easy. Why? Because as calculator is not allowed in this examination. If you write the KVL, KCL, you can get, but you are going to get equations which are need to be solved. But here without a calculator we solve. So that is very important. So there are many methods to solve any given network, but which method you have to choose is going to depend on the given question. You have to select method in such a way that it must avoid calculator use, or calculations must be simple. Next question. A coil of 0.02 millihenry is carrying a current of 1 ampere. If the current is reversed in 0.02 seconds, EMF in the coil is, good question. Coil means inductor. What is voltage across inductor? VL is equal to, or EMF is equal to L into di of t by dt. So that is equal to L into di of t means I2 minus I1 by, this is t, delta t or t, dt I'll write as. So he said that L, how much is L? How much is the inductance value? A coil of 0.02 millihenry. So 0.02 into 10 to the power of minus 3 into I2. So initially the current was 1 ampere. Now it is suddenly got reversed. So I1 is 1. So this I2 is minus 1 by I1 is 1, I2 is minus 1 by dt. How many seconds? In 0.02 seconds. This 0.02, this 0.02 gone. We are left with minus 2 into 10 to the power of minus 3. That is nothing but 2 millivolt, minus 2 millivolt. In fact, the option is A. Option is A, but that fellow did not given that minus. He is considering only magnitude. When there is a sudden change of current through inductor, we know that voltage polarities will get reversed. Voltage polarities will get reversed. It is minus of 0.002. Right? Choice is A. Next question. What is the power supplied by the DC source, by the DC voltage source in the circuit shown below? Yeah. He is asking what is the power supplied by this one. So simply V square by R. But R, there are many parts. So let's consider into as let's make it into one part. So this is DC voltage source of 3 volts. 6 in parallel with 3 will be 2. Yes. 3 into 6 by 9. 3 3s, 3 2s. Yes. Yes. It is 2 ohms. 2 ohms it is. And this is 1 ohm. Right. Now this is plus minus 3 volts. This is a 3 ohms. Now power is equal to V square 3 square by R. So power is equal to 9 by 3. So power is equal to how much ma? 3 watts. See, this kind of questions only previously asked in many PSU examinations. Right? Let's go to the next question ma. The root of L by C has units as, see, I'll tell you, root of L by C. Let's take a root of L by C. I can write this one as root of L into omega by C into omega. You all know that inductive reactance XL is equal to omega L, units are ohms. Capacitive reactance XC is equal to 1 by omega C, its units are also ohms. Now, this one can be written as omega L, its units are ohms. This is omega C, but this is something like I can write it as 1 by omega C. 1 by omega C. So this combined units are ohms. This is ohm, this is also ohm, under root ohm square will be ohm. I am writing about units. Answer is ohms. Just that much simple it is. Or if you remember some formula like ZC is equal to root of L by C. ZC is equal to root of L by C. Electrical guys. Under root of L by C. Under root of L by C. Ohms. That is characteristic impedance. Electrical guys know what is ZC. Characteristic impedance it is. Right? Yeah. Next question. The frequency of a signal is inversely proportional to which of the following? Frequency. We all know that frequency is equal to 1 by T. So frequency is inversely proportional to the time period. That's all. That is nowhere related with phase or power or amplitude. Right? Let's go to the next question. In the circuit shown below, if I1 is equal to 1.5, he is saying that this current is 1.5 amperes. Then I2 will be, he is asking us to find this current. So I do one thing. See, most of the cases I will follow current distribution method. I know this current, I know that one, this one as I2, this one as I2. Let's write KVL, that's all. How much it is? Minus 6 plus 2 into, just a minute, minus 6 plus 2 into 1.5 plus 2I2 equal to 0. Yeah, that fellow himself given the current as I2 in that. So I need not to write anything. 2I2. In fact, I want to find I2 only. So minus 6 plus 3 plus 2I2 is equal to 0. So 2I2 is equal to 3. Minus 6 plus 3 is minus 3. Therefore, I2 is equal to 1.5 amperes. I2 is also simply 1.5 amperes. Let's go to the next question. For the circuit of a figure, below figure, the voltage V1 and V2 are, simply apply voltage division. Apply voltage division. That is, V1 is equal to 20 into 2 by 5. V2 is equal to 20 into 3 by 5. So this will be 5 fourths. This is 12 volts, this is 5 volts, this is 4 volts. If you add these two, somewhere I committed a mistake. This is 8 volts. In the multiplication I committed a mistake. 8 plus 12, V1 plus V2 must be equal to 20, you can check. Yes, 8 volt and 12 volt. Option is A. But here I didn't observe carefully. He taken polarity minus and plus, this way is measuring. Therefore, this is, I'll erase this one, So this is not correct. V2 is, so V2, he mentioned V2 minus plus, therefore it is minus of 20 into 3 by 5, it will be minus 12 volts. Yeah, this kind of simple silly mistakes will commit if you are not looking at the polarities carefully. If he is giving plus minus like this, directly you can apply, but he taken opposite polarity as V2, therefore so 8 and minus 12, you see first option itself is very attractive for us. We are going to take it, we may get negative marking if there is, and otherwise if we are going to lose the mark, right? Observe the question carefully. So it is minus 12, right? Let's go to the next question. In fact, this 8 volts, this voltage is V1, this voltage is minus V2. Why? Because as current is flowing, this is plus, this is minus, but that fellow taken minus plus, his convention, we can't do anything, right? We can't do anything. So summation of those two voltages must be equal to 20 volts. Yeah, an EMF 8 volts is induced in coil of inductance 4 Henry. So what he is saying is, there is an EMF of 8 volts is induced in a coil of 4 Henry. V is equal to L di by dt. What is the rate of change of current? So he is asking the same. Di by dt is what? What does it mean by rate of change of current? Di by dt. So di by dt is equal to 8 by 4, that is 2 amperes per second. That is 2 amperes per second. Choice is A. Let's go to the next question. Find the wavelength for a sinusoidal signal of 50 Hertz. So wavelength lambda is equal to, yes, V by F. What is V? V is the velocity of the wave. That is with what velocity voltage and current waves will travel? 3 into 10 to the power of 8 meters per second. By it is frequency is 50 Hertz. Remember that formula. Okay, lambda is equal to, wavelength is equal to V by F. So if you simplify that one, lambda is equal to 300 into 10 to the power of 6 by 50. I do, this is got cancelled. Lambda is equal to, yes, so 56 it is, 56 times it is, yes, yeah, so lambda is equal to 6 into 10 to the power of 6 meters, but the same I write as 1 meter is equal to how many, 1 kilometer is equal to how many meters? 1000. So 6 into 10 cube into 10 cube meters. This 10 cube meter can be taken as, 1 kilometer. So lambda is equal to 6000 kilometers. 6000 kilometers. Choice is A. Let's go to the next question. Read the question. This question is also very simple question. Two inductance coils, each of 2 Henry, are connected in series and are magnetically coupled. The coefficient of coupling being 0.1, the total inductance of the combination is, this is the formula for equivalent inductance. This is the formula for equivalent inductance, that is L equivalent is equal to L1 plus L2 minus 2M. She is saying that L1 is 2, L2 is also 2 into M is K into root of L1 L2, that is 2 plus 2 minus 2 into 0.1 into root of 2 into 2, right? Now what you are going to get? So L equivalent is equal to 4 minus 0.2 into 2, that is 4 minus 0.4, that is equal to 3.6 Henry. L equivalent is 3.6 Henry. Clear? Let's go to the next question. The value of resistance R in the following circuit is, he is asking about the value of this resistance R, right? Now these these two are in parallel So simply do the parallel combination. This is R ohms. This 10 in parallel with 10 is 5 ohms, and this is 100 volts. This is 8 amperes, right? 8 amperes. Let's write KVL. Minus 100 plus 8R plus 8 into 5, 40 is equal to 0. So 8R is equal to 60. R is equal to 60 divided by 8. Just do that, you are going to get yes, 60 divided by 8. I think it is not 2.5, it is not 5, it is not 10, it will be 7.5. Yeah, it is 7.5, right? Option is B. Let's go to the next question. If the length of cable L and its capacitance is C, now the length is doubled, that is 2L, then its capacitance will be, see, capacitance C is equal to epsilon A by D. But that A is area, that is D is the distance, So area, I can write this is area by distance is D. If I take, so he is asking about the cable, so this is the cable. Don't compare with a parallel plate capacitor. This is a cable looks like this. This is a cable, right? Now see, the capacitance that is formed in a cable, will be like this. This is the formed capacitance. This way capacitance is formed. Now all the capacitance are connected in parallel, right? All the capacitances, these capacitances all are connected in parallel. In parallel combination, capacitance will be added. Now suppose if I take this one of length L, now length L is having a capacitance of C, 2L is going to have a capacitance of 2C, that's all. Don't take any formula, don't take area formula and D formula, nothing, not required. None of the formulas are going to help. Why? Because this is a capacitance of a cable. Means see, you can observe this way capacitance is formed. Now all are in parallel, all parallel combination will be added. As you are increasing the length, the number of capacitance formation will increase, total summation will increase, therefore it is going to be double. Answer is 2C, right? Let's go to the next question. A voltage source having an open circuit voltage of 100 volts and the internal resistance of 50 ohms is equivalent to a current source of, this is very simple. He is asking, there is a voltage source of 100 volts and resistance of 50 ohms. Now this can be represented equivalently with the help of current source. What is the value of current source? 100 divided by 50, that is 2 amperes, and in parallel with the resistance of 50 ohms, that is 2 in parallel with 50. Let's go to the next question. The charge on a 20 picofarad, not microfarad, the charge on 20 picofarad, C is equal to 20 picofarad capacitor when 20 kV is applied, Q is equal to C into V, that is 20 into 10 to the power of minus 12 into 20 into 10 cube. So this will be 400 into 10 to the power of minus 9 coulombs. Now that can be written as 0.4 into 10 to the power of minus 6, that is equal to 0.4 microcoulombs. The option is C. So this way we can solve all the questions very simply which are having the probability of being asked in HPCL examination, right? So almost all the areas, every week this series will come, question series, all the areas of subjects like control systems, network analysis, these subjects I will be covering. Thank you.